So we are looking at this map now, right? Looking at this map, and all of the roads are going to symbolize equations. Okay, roads symbolize equations. What do you think it means for there to be a solution between two equations? Yeah, where they intersect with each other. So Newton and Shirley. Newton is right here, Shirley's right there. They intersect at point A. General de Gaulle and Woodland. General de Gaulle, Woodland. Intersect at point C. Why do you think it says no solution for General de Gaulle and Manhattan? They don't intersect. Exactly. So can you finish filling out the rest of the table, please? Finish filling out the table. So fill out the table. Once you finish filling out the table, you can answer the summarized questions at the bottom. So what is the meaning for a point to be the solution of the equation? So what does this point C, what does it represent for those two terms? Yeah. Damon, can you get back to work, please? And Daniel and John. Nope, it's saying where do those two roads intersect? Yeah. Where do they cross? Do they cross? No. So what happens when we get the Where's Carol's? Okay, so where does Whitney and Carol Sue intersect? Point D. Perfect. Right, Whitney's right here, Carol Sue's right here, point D is right there. D. What about Franklin and 428? Exactly, no solution. They never intersect. But what about 428 and Carol Sue? Point E, perfect. Okay, and then for the last few, it asks, it gives us the solution, and we need to figure out what the roads are that would produce that solution. So point V. Huh? Yeah, Highway 90 and what? And Whitney. Good. What about point D? Yeah, Whitney and Carol Sue, it repeats. And then what about two roads that would produce no solution? Yeah, good. Franklin and Woodland. Can I get another pair of roads? Huh? Highway 90, I didn't hear the first thing. And Newton. Yeah. Yeah, good. What else? Woodland and Whitney. Perfect. Yeah. So any roads that just don't intersect, that could go there. And what does it mean for a point to be a solution to two equations? Like, what do those points represent? Yeah, it just means that those two roads intersect. The roads or equations intersect. Good. And what does it mean if two equations have no solution? Huh? The street's not correct? Yeah, they don't connect. They don't intersect. The roads or equations do not intersect. Good. Is it possible for two equations to have more than one solution? Huh? Yes? How? Do you see an example that of two roads that have more than one solution on the map? Carol Sue and what? So yes, it connects because it connects to Whitney and it connects to whatever street this is and it connects to 428. But think about two roads. So let's say like Whitney and Carol Sue. Is it possible that they could intersect in more than one place? No. Where does Highway 90 intersect with? Huh? With Franklin, right here, and right here, right? Highway 90 also connects with Whitney, right there, and right there. So it is possible for two roads to intersect more than once, but what has to be true about one of them? Yeah, it has to be curved. So, okay, so hold up your arms. Hold up your arms. Okay, so these are like our systems of equations. We have two equations. You can have two that are just straight, that are just like this, that are parallel. You can intersect, right? But you can only intersect once. The only way you're going to get your arms to intersect more than once is going to be to like, you know, do some type of curvature of some kind, right? If we just have straight lines, yeah, if we just have straight lines, it's only going to connect once. Unless you have two of the exact same lines, then it's going to connect infinitely many times. And we'll get there, I don't know, I think tomorrow we'll talk more about that. Okay, so the only way for two equations to have more than one solution is if one equation is nonlinear. So if it's not straight. So yes, it is possible. One road or equation must be nonlinear. Nonlinear. By nonlinear, I just mean not straight. You guys okay? Okay, flip over to the other side. Okay, same kind of idea for this side. up at the top, but instead of roads on a map, you just have lines on a coordinate plane. And they're all nice and labeled for you, right? So y equals x, that's right here. Y equals negative 0.25x, that's right here. Those two lines intersect right at the origin. So I put for my solution 0, 0. So for all of these, your solutions are going to be what? What are these called? Coordinates. Yeah, ordered pair. Ordered pair is really what I'm looking for. So the solution is always going to be an ordered pair, x and then y. X and then y. Okay? So go through, figure out your solutions, and then figure out your equations down here. Finish filling out the table. If you finish filling out the table, you can answer this question down here. Yeah, just sign up and take class. Thanks, Benson. So try and start drafting this. Putting to graph. You should have 2 lines for every graph. So this second part says y equals x plus 5. That's going to be right here. And then y equals 4. That's this line right here. So they intersect right at this point. What are the coordinates of that point? Yeah, good. -1, 4. So always our solution to systems of equations is going to be an ordered pair, x and y. What about y equals 4? Right here, that same one, and y equals x. Where do those intersect? Yeah, 4, 4. 4, 4. What about y equals x plus 5 and y equals x? Good. Yeah, there's no solution. Those never intersect. And tell me this. So y equals x plus 5. What is the slope of this line? What's the slope of y equals x plus 5? What's the slope of this equation? Not 0. What is it, Damon? Yes, 1, right? There's an invisible 1 in front of that x. So the slope is 1. What is the slope of this? Y equals x. It's also 1. So that tells you something. So parallel lines have the exact same slope. So if two equations have the same slope, there's no solutions because they're parallel. Okay, now they give us the point and we got to come up with the equation. So -4, 1, that's right here. What two equations meet at this point? And what else? -0.25x. Good. What about -5, -5? Y equals -5, and what's the other one? And y equals x. And then what about two lines that have no solution? Perfect. What about another pair? I guess we already said the other one. Y equals x plus 5 and y equals x. What about this line? Y equals -0.25x and y equals -5. Do those intersect? Yeah, eventually. Exactly. So if I like continue those lines, they would intersect at some point. So we can't say those two don't have a solution. Because just because we can't see it doesn't mean it doesn't exist, right? Okay, and is it possible for two linear equations to have more than one solution? No. Why not? Yeah, right. We just said it on the other side of the paper that in order for there to be more than one solution, one of the lines is going to have to be curved. Linear equations are always straight. So you can have at most one solution. Linear equations can only intersect once. Can you please put your phones away? Okay, finding the solution to each set of equations by graphing. So in order to find a solution to a system of equations by graphing, we just need to graph both of those lines. So for each one of those, you're going to graph two lines. What form are all of these equations in? What form are all 6 of those equations in? 1, 2, 3, 4, 5, 6. How many? What form? Slope intercept. What does slope intercept form look like? Excellent. Y equals mx plus b. What is the m? Slope. What is the b? Huh? Y-intercept. Good. So if I'm given an equation and I need to graph, what do I need to do? If I'm given an equation in slope-intercept form, how do I graph it? No, y is already solved for. Y is all by itself. No. Yeah, so start with the y-intercept. In this first equation here, what's my y-intercept? 4. So I go up to 4 on my y-axis. And then what do I do? Yeah, use your slope, and your slope is rise over run. So -3 is like -3 over 1. So that means I go down 3 over 1 from the y-intercept. The y-intercept is our starting point. So we go down 3 over 1, down 3 over 1, down 3 over 1. And that's our first line. Is that it? Am I done? Is that my answer? No. What do I do now? I have to graph my second equation, don't I? What's my slope of this second equation? Yeah, 1. And what is the y-intercept? Yeah, it's 0. Yeah, at the origin, right? When we don't see a y-intercept, we can like assume that we have that +0 there. There's kind of like an invisible +0 there. So 0 is our starting point, and then my slope is 1. What does a slope of 1 mean in terms of rise over run? Exactly, up 1 over 1, up 1 over 1. So I do that, and I'm there, Can draw it all the way out and be really thorough. And now I have 2 lines. And is that it? Am I done?
No, you find the solution.
Yeah, where is the solution? Where the 2 lines intersect. So what is that point where the 2 lines intersect in this example?
1,
1, 1. So you give me an ordered pair for the solution. Okay? So finish up numbers 2 and 3. And we've got plenty of time right now. There is a Delta Math assignment. So when you're done with this, you could start working on your Delta Math because that's due at the end of the week. And this needs to get turned into the inbox. You can turn your Cortez Math in too.
So the x or the y of is 2.